Good day, everyone. I'm Roy Richardson, Vice President of Business Development for CelPlan Technologies. Welcome to the Wi4NET CelPlan and Secured Cities webinar on campus video surveillance and best practices. Today's presenter is Mr. Jasper Bruinzeel, who will give a more detailed introduction of himself once I turn the floor over to him. Just a few housekeeping matters to go over before we start the session. During the webinar, all attendees will be in listen-only mode. If you have any questions during the webinar, you will see in your panel that there is a hand icon that you can actually raise to ask a question. We will take breaks during the presentation to answer questions. We may not be able to get all the questions during the presentation, and those that we're not able to get to, we will certainly answer via email. So please do send in your questions. Depending on your internet connection, you may encounter screen refresh issues from time to time. If that does occur, please click on the button that toggles from full screen to window and back to force an update of the screen. There's also a chat window where you can ping us if you encounter any issues during the webinar. With the housekeeping duties out of the way, and without further ado, I'll now turn the session over to Jasper. Jasper?
Yes, good day. Welcome, everyone. Thank you for joining. And so I'm Jasper Bruinzeel, and with me today is James Bailey. He's the Terminal Manager with the Port of Richmond, Virginia. Hello, Jim.
Good afternoon.
Yeah, thank you for joining us. Before going into the agenda for the webinar, I wanted to give just a little bit of background. I work for CelPlan, and specifically our Wi4NET division. And that basically is the system integration group focused on security systems. We've been collaborating with the Secured Cities organization for a number of years, and together we came up with this concept of a webinar series leading up to the annual event in Baltimore this November, basically as a sampler of that event, so to speak. And for years, Secured City has been putting together conferences about case studies, best practices, latest technologies, with a specific focus on cities, police, education, transit, and healthcare. And our area of focus as a system integrator is aligned with those same kind of markets. So without much further ado, I'll go a little bit more now into the purpose and the focus of the webinar today, which is around campus video surveillance. To be clear, this is part two of a two-part series. In part one, we focused on citywide and wireless type of surveillance systems. This time, we're focusing on campus surveillance. The main case study today is the Port of Richmond, and obviously Jim with the Port of Richmond will take the lead on explaining his project to all of us. So for today, I have just a brief introduction. We'll have the case study where Jim will take the lead, and our thought is that this session will probably close within the hour. But in order to allow people to ask questions and kind of wrap up the part of the case study, we have the idea of a Q&A session at the end of the case study. So if you have specific questions for either of us, but specifically for Jim and the Port of Richmond project, please type those as he's talking so that the questions are ready. And Roy, the moderator for today, he will bring out some of those questions at that time. From there on, I will kind of move on and address, first of all, a couple more case studies. There's a university case study, another type of campus, an airport, and a utility case study that we'll address that brings some other aspects of campus surveillance. And then in terms of the technology items for today, we'll talk a little bit about video management software and also back-end hardware solutions, storage type of architectures and calculations. We'll talk about analytics, video analytics, and some examples of that. And then finally, we have a topic of just kind of a number of different specialty items around using cellular for backhaul, mobility aspects that are enabled through cellular, and some specialty video solutions that are available. I figured that a number of the attendees today might have attended the webinar part one, and some might not have. So just a really quick recap of webinar part one. We looked at a couple of trends, and my opinion is that basically the industry has really moved from analog to IP, and you'll see that all the case studies are based on these kind of principles. Analog cameras still have a place. If that means a cost-effective way to increase your camera count, increase your coverage. I believe that people are now thinking in standard terms about covering multiple locations because software makes that possible. And then people are also looking beyond just surveillance cameras, things like access control, ALPR, integration with GIS, mobility, mobile devices. And Jim's project with the Port of Richmond, I think, touches a little bit on that. Another reason I wanted to mention this again. I already mentioned last time we talked about citywide rather than campus. And in terms of the technology topics, we talked about camera best practice design and wireless best practice design. We'll leave that aside, but for those who are interested in those topics and missed the first one, let us know. There are links to tie into the previous one. For this webinar part 2, so to really kind of get started, so campus surveillance. I tried to kind of think for myself and what is really unique about campus surveillance. And I came up with my own little definition here. And first of all, I figured that, well, it's beyond a single facility in order to have a campus-style project. On the other hand, it's more manageable than, let's say, a citywide or a regional project. In a campus setting, usually you own the premises. If there are trees in the way for a wireless link or running conduit or trenching, usually you have the ability to get rid of the tree. There's a lot of ownership that you have. The area is usually a little bit more contained. And that means that you can put up a really high quality, well thought out system within the campus setting. So it gives a lot of freedom. It also puts some pressure because you really should be putting together something that works really, really well. In terms of networking, both fiber and wireless would be options. Fiber is probably still more expensive, but it provides higher speeds. So it's a trade-off. And there's a little university example that is kind of written here. I believe in yellow are wireless links that are used, tying cameras and locations back to, in blue are the end nodes, which are basically facilities that are throughout campus. This is, I think, just a small part of it. And these facilities then have fiber in between them. So it gives a little bit of an idea where it's actually a combination of fiber and wireless that is used in that specific project. Typically in a campus setting, we have to deal with both indoor and outdoor settings, where in a facility everything might be indoor. Typically in a campus we would be looking at some outdoor cameras too that have their own needs, their own specific problems and issues. And then I think this one is a little bit unique. A campus might have a specific parameter, a fence, and that is something that has its own possible solutions to cover and protect the fence line. And I have, we have some case studies that touch on that, less so the city of Richmond, but some of the other cases, more so some of the other case studies. The trend, again, this is one slide from the previous session, but very quickly, City of Richmond does not only have PTC fixed cameras, they also have ALPR, they use remote monitoring, they have access control, analytics, and they're also using this network, which is not really outlined here, but they're using it for other purposes. For example, for Wi-Fi connectivity throughout the port. So the thought of thinking of not just this system as a surveillance system, but thinking beyond it as a system of communications, of security, of different ways, it gives more bang for your buck if you allow yourself to think outside of the box. A trend also from last time, the LTE cellular possibility that now is available. It allows you to take cameras and put them in mobile situations. LAPD is one example that we'll talk about a little bit with mobile cameras. And we'll touch on that a little bit later at the end. So with that, Jim, if you can give an introduction of yourself and start the summary of your project.
Sure. My name again is Jim Bailey. I'm the terminal manager at the Port of Richmond. As a means of background, we had no a very low technology operation here for many, many years. It's a 34-acre developed facility with 300,000 square feet of warehousing. And we handle barges and ships, mainly carrying ocean cargo containers that you would see, the big 40-foot steel boxes, if you will, between Central Virginia and the ports down in Hampton Roads, and some, as well as some domestic rail traffic. As our business has changed over the years, and the need to access warehouse management systems and yard management types of systems, and then deal with changing security regimes, we found ourselves in need of a better way to access the terminal operating systems, and at the same time better surveillance capabilities so that we could further enhance our U.S. Coast Guard approved security stance. So some of the challenges that we encountered, and as we were sketching out what we thought we might want as part of the whole system, every day that we come into the port, the landscape of these cargo containers stack some as much as 5 containers high and 10 deep. Every day that landscape changes as the cargo comes in and moves back out by truck and rail. We had some historical preservation kinds of challenges. The bulk of the facility was constructed in 1939. As you see there, the nameplate on there has Franklin Roosevelt on there. So we had some historical things that we wanted to make sure that we did not disturb. And then also, we were on a fixed budget, and so the ability to cut into that budget to reroute power really was not available. So we ended up having to constrain ourselves to the existing light towers and power infrastructure here at the port. I'll ask Jasper to comment a little bit more on some of the design challenges from CelPlan's point of view in the next couple of slides.
Yeah, thank you, Jim. So this slide and the next slide, again, they were in the previous webinar, but the point is that I believe it's so important to have that realization when you embark into a project that, and I think for Jim's case that was the same, there were certain kind of starting point requirements or expectations of requirements that were kind of put to paper, and there was an RFP process, frankly, that started this project. But the Port of Richmond, they very much kept an open mind and were able to really kind of do their research with vendors for different directions and with different inputs to try and come up with the maximization of those funds that were clearly limited, but try to kind of get the best system and the most useful system out of the requirements. So where there were some initial thoughts that are not specific like stated here, but there were some specific ones, but eventually we went through that cycle that we kind of discussed the previous time, and we went through that a couple of times in a couple of circles, if you will, to come to that final solution. And that final solution is on the next slide here, specifically for this project. In terms of one key challenge, of course, with any of these campus systems is that you saw a picture of the port. It's a fairly large facility. Trenching that whole thing up for fiber, for one camera here, one camera there, that would absolutely be cost prohibitive. So wireless was the logical choice to connect to cameras that were on different sites. The sites that we picked were logically different kind of light poles that were spread throughout the facilities, and as Jim indicated, the problem was that they were centrally switched, and every time that we had 2 or 3 poles in a line, we needed only to use one because the other one was right next to the first one, and they were all in one circuit. So the solution that we came up with was to basically convert all poles in the premises to photocells, and that way have permanent power at all of them, and at least not having to rewire to every pole individually. So that way we avoid trenching also related to power, but there was quite a little bit of extra work. But in a sense, at least, it was a cost-efficient way to get power to all the poles, including the ones that we needed to have power to for our system. So that was one of the challenges. But at the same time, and the other element was that, and there's been a lot of marketing around Wi-Fi mesh systems and the fact that they have redundancy. And we spoke about that a little bit, wireless best practices. So as we indicated last time, video really is a killer application for wireless in general, and particularly for mesh-style systems. So we said, well, a scheduled protocol might be the smarter way to go, and there are ways to do that with redundancy as well. We looked at a couple of trade-offs. So we did a bunch of trade-offs, mesh, point-to-point, or a point-to-multipoint system, which is in the end what we selected, and a ring architecture as well. And we just kind of went through the homework, through the different options. And in the end, we said, well, it is possible to do it redundantly without breaking the bank too much. So we ended up going with a scheduled protocol, point-to-multipoint architecture, and then a fully redundant solution. And it did pay off. In one case, we found that one of the brackets was twisted and that the radio was no longer in good position, and the other radio basically had taken over without knowledge. So redundancy is possible in many different architecture if that's a requirement. So redundancy and reliability was a key factor. The other one, I think it's a very interesting one, is that they were kind of looking out of the box and said, well, this is a surveillance system, yes, but can we do anything more with it? And the Wi-Fi layer aspect became very important, as Jim mentioned. So there's been a transition in terms of how to run the paperwork and tracking of assets and things like that on the port. And the preferred method these days is with mobile devices connected through something like Wi-Fi and some kind of high-speed connection. And in fact, the system also allows to view the cameras that way, of course within the Wi-Fi limits. But what Wi-Fi brings here, Wi-Fi has its own application. So for mobility, for standard devices, it is the logical technology of choice. So what we really did is we combined that scheduled high-capacity backhaul to all these different poles, and then we said, well, gee, we already have cameras kind of nicely spread throughout the premises. If we just add a Wi-Fi access point in those same locations, what kind of coverage can we expect? And I have a next slide that explains that a little bit. But other than that, so there's a combination of PTZ and fixed cameras, including megapixel cameras to get good quality images. And then there are ALPR cameras, automatic license plate recognition cameras. Here's an example of that kind of camera that was positioned at the entry points and the exit points, along with also some analytics capabilities. So in the next slides, I think this one is somewhat interesting because we said, well, Wi-Fi, it has only limited coverage. What kind of coverage can you expect? And then there was that mentioning of these stacks of containers that are made of metal and are basically barriers for wireless propagation. So we actually did a number of propagation analysis for this project, and including basically a simulation of the structures that were on that port facility. So, for example, here there are different facility buildings, and you can see here there's an access point actually inside the building, and what you can see is that in red, obviously that is the best coverage in these different circles. The red, provides good coverage, and the coverage drops as you move away from the access point. What you can see here is that the wall that marks the end of that building, you can actually see that the red stops right there, and then behind the wall, it has a lower type of coverage. So it gives a little bit of an idea how accurate these kind of simulations can be. The other thing is here, obviously the red stops right at, these are stacks of containers right here. There's a stack of containers right here, and you can see the red basically just stops right when it hits the stack of containers. So, I think in the end we predicted some little lower coverage spots, but overall it gives a good idea of what to expect with the type of Wi-Fi coverage we were able to put into the initial budget. And Jim, I think you'll take it from here.
Sure. the funding source for our project, we were going through a FEMA port security grant, which is awarded each year to ports all across the United States. In the project year, we wanted to include the cost of purchasing and installing the entire system, and then the first year of support and maintenance for it. Funding for the additional support and maintenance comes through additional grant programs that we're involved with. In terms of how to maximize the usefulness of our budget, we really had to go through that value maximization process that Jasper mentioned a number of different times. We had our own wish list of what we thought were the features that we would like to have. Did we want all sorts of analytics? So if someone crossed the fence line, we would be alerted. Did we want more cameras, fixed versus PTZs, expanded Wi-Fi coverage? All of those kind of things were on the table as we started sketching out the system. What we found through going through that value maximization process was, yes, we can trade features and get better coverage for camera coverage or Wi-Fi coverage in areas that we thought that we needed it the most, and tried to really take into account what's the highest and best use of that available grant dollar. And then, at the end of the day, having gone through that value process several times with a multifaceted team, including operations folks, security, IT, and finance, we ended up making some trade-offs that, at the end of the day, weren't as painful as one might imagine. We ended up sacrificing what a perceived need for sophisticated analytics for additional PTZ cameras and expanded Wi-Fi coverage. So as we went through that multiple times, you're really able to narrow down exactly what is critical to quality of the system that you're looking to install. So moving on to some of the successes, we decided to go with the Genetec interface. It's very easy to use. It's easy to train new users for. And for our small non-IT proficient staff at Port of Richmond, it's easy to administer and initiate. The back office functions are very easy, and even if you haven't been consistently going into those back office functions, it's intuitive. You can find your way to what you need to find. Great access for archived video footage, which we draw on from time to time. The Wi-Fi layer is reliable for us. The bottom picture there is actually an iPad that we use to access both the camera system if we're walking around the facility, and we also access our terminal operating systems through the Wi-Fi layer. And then the support that we receive through the annual maintenance and support contracts is second to none. We've got a lot of the maintenance and the firmware upgrades, and there's a lot that happens behind the scenes that I and my staff never know is going on, and that results in a final product that works very well with uptime of far greater than 99%. And any downtime, Jasper mentioned that we did have a bracket that we found in this year's annual maintenance that had come loose, and we had one antenna that was not functioning at optimal, but that redundant architecture that we designed into the system was such that our security folks and our staff using the system had no idea that anything was going wrong. So the next slide shows a screenshot of what the Genetec interface looks like. It's very simple to use. It can be set up with a joystick, or the blue circle there on the right side of the screen is you can operate with a mouse and move your PTZ cameras wherever you need to go with them. Some of the pictures that are included with the presentation today were actually taken from these cameras, and we use them for our marketing and sales efforts. But very easy to navigate. You simply double-click on the camera that you want, and it pops up into the bigger window there. We also use iPads and iPhone apps. Personally, I'm more prone of using the pulling up the cameras on my iPhone. You can maneuver them exactly the same way. Take snapshots, which populate right into your iPhone's picture directory. We also have the ALPR side of things, and we're able to read the license plates of not only personally owned vehicles, but more importantly for us, the cargo transport vehicles that come in and out of the port. Overall, the successes that we've experienced in the last, I guess, 2.5 years of operating with this system, we're better able now to access our terminal operating systems, through the Wi-Fi layer, instead of checkers out in the yard with paper and clipboards. They all have iPads now and Panasonic Toughbooks and products like that that allows us to provide live inventory updates to our customers through EDI links and terminal operating systems. We don't have to rely on cellular networks because we have this Wi-Fi layer now. It's an easier process for our clerks, and it's more time efficient. And our customers, at the end of the day, receive more timely and accurate information concerning their cargo movements. It's updated live and in real time. So really that second layer of the two-channel radios there really gives us a distinct advantage commercially and operationally. The photo on the right here is, again, one that was taken from one of our PTZ cameras that we use pretty often in marketing correspondence. But looking ahead toward the future, when we designed the system, we wanted it to be expandable, both inside and inside the warehouses and other locations around the terminal, and that's what we got. So as we increase operations in various areas, we have that ability to drop in a camera and another Wi-Fi access point wherever we have power available. Integrating that ALPR data into terminal operating systems is also a kind of a next step for us. It's not a highly demanded piece of data right now, but as we move forward and our volume increases, that's another step that we can take. Access control modules for our administrative and operations buildings is another way we might go in the future. And then as we do more with our warehouse capability, adding interior Wi-Fi coverage. We have a bit of coverage that, depending on where you happen to be, from the outside antennas that do project somewhat into the concrete buildings, but that interior layer is something that we're planning on doing here in the not-too-distant future.
Okay, Jim, thank you. Roy, would there be any questions that have come in so far that we can address?
Yes, Jasper. Jim, would you have lessons learned and general suggestions for others planning such a system?
Sure. As we entered into this project, everybody around our table had a list of what they wished the system would do. My recommendation would be to think very hard about what you want that wish list. What are the must-haves versus the nice-to-haves, if you will, and really try to boil it down to what ends up being critical to the quality of the system, and go through that value maximization process, as many times as it takes to arrive at a consensus on your team, and then working with your integrator. Redundancy is something that, especially here after learning that there was a problem with an antenna, the redundancy is one that we're very happy that we insisted on, and that CelPlan insisted that we include. And then the team approach to everything. You need to have operations, security, finance, and IT on the team as you go through that value mapping and maximization process. But those are kind of the top lessons learned from our project.
Okay, I have a few other questions here. Did your grant cover security staffing at the console?
Right, you're breaking up.
Okay. Did your grant cover security staffing at the console?
No, our grant was written specifically with the purpose of acquiring a camera system. We were able to create a system that had more than just a security aspect to it, which we felt was very creative use of those dollars. But that was the limit of the scope of that grant.
Okay, I'll do one more question here, and then we'll move on. What method did you use to select the camera locations?
Well, we at our facility, we know where the concentration of activities happen to be, and perhaps Jasper, if you could move us back to one of the earlier slides, 13 or 14, perhaps, that show the facility from above. Maybe the next one there. So along the riverfront, near that node where the Jasper's pin is right now, that's our dock. We operate the vessels right there, so we know we wanted to have some visibility of the riverfront, and then have visibility in between each of the three warehouses, and then at several other key points throughout the container yards. And when we were trying to pick locations for the cameras, we also took into account where will the containers be stacked and how high will they be, and will the camera have a good enough view over the top of that, say 80 or 90% of the time. And then up at our front gate, obviously we concentrated the fixed and megapixel cameras and the ALPR type cameras up there. But that really came down to an operational preference. The IT folks also weighed in on. We adjusted some of the locations because we wanted greater Wi-Fi coverage right there on the dock. So you'll see where Jasper's pin is right now. There's a concentration of the red areas that have better Wi-Fi coverage for vessel operations. So we changed some things along those lines to. So it's really a trade-off, and comes from knowledge of your facility and what you want to look at and what you're trying to achieve.
Okay. Thank you, Jim. So with that question answered, I'll move on to a couple more case studies, but different ones, and I hope bringing kind of different aspects on this topic of campus security. So the next one would be a very different environment, a university campus in southern Texas. And some of the challenges that they had, as you all know, universities, they have used surveillance systems over the years, as had this university as well. They had different facility systems mostly. They had some systems in their busier parking lots, But basically the system was, although it was an IP system, it was more of a proprietary nature. The type of company that sells the hardware, the software, and the cameras, and where I think I hinted the last time that there is that kind of conflict of interest sometimes where it might not be a leading camera, but that's the camera they offer. So we always try to kind of promote a best-of-breed approach where in the end you tend to spend less money, but you get better quality and more flexibility to the end user, and that was something that they were interested in, as well as they had the need to cover the parking lots really throughout the campus. And that required a fairly large investment. Of course, the budget was limited, but there was some money allocated to make that big step forward. And the question was, well, do we keep kind of the same legacy system, or do we try to do something different? Of course, there are continuous needs here. The campus is expanding quite rapidly. I think they have 20,000 students right now, but I think they're growing to 30,000 just in the next few years. And another element was that they did have some existing cameras in the parking lots, and I think they were only kind of like a 1 megapixel style, but they selected some kind of Wi-Fi based wireless solution, and it was kind of that whole killer application story. It wasn't able to handle even the 1 megapixel cameras very well. I think they had to downgrade the resolution, the frame rates and everything, so you ended up with a little bit of a poor quality image that would run over the wireless links. So the solution that we ended up going with, and well, maybe to go back, where possible we would put cameras on top of the facilities, and we would use specialty lenses to kind of focus on certain areas. This is just kind of a zoom in of that, I think the same location. And in some cases we would use a wireless connection. You can see the kind of the panel antenna here. And the cameras might be out in the parking lots closer by to the areas of interest. But in general, so in the end they selected an open architecture software that not only could deal with any kind of new camera from any kind of brand, but was still able to tie in the old cameras as well. This campus had an existing fiber network, mostly connecting buildings. So in order to get to those light poles, you still ended up needing some kind of wireless connection. In terms of the back-end solution, they were able to basically centralize things. So the campus police force was located in one central office. Ideally, everything would come together there, and with the campus network and the fiber network in place, it was possible to actually bring all that video back to one central location. And in that central location, it's very easy to build a scalable multi-server, in this case, a multi-server solution. So I think we started off with three servers. I think we're going to 5 servers now. Basically, and then the storage can grow with that as well. So, but the idea is that, of course, to the user, it's kind of transparent. It's a system that can scale, but without really the end user knowing that it is actually scaling if it does. For those parking lots, we ended up going with 5 megapixel cameras in order to get good coverage, but trying to find a balance. So, and in the previous webinar, we talked a little bit about how many pixels you need for facial recognition, how much cameras you need, and we're talking about a lot of parking lots. So we ended up with 75 5 megapixel cameras. It's a lot of bandwidth, it's a lot of storage, a lot of bandwidth over wireless connection. So overall, this is kind of where we found that balance point, and I think we ended up with 10 to maybe 25 pixels per feet, roughly, if I remember correctly. So not quite to the 40 pixels per feet, but this was something that was understood and engineered from the beginning, and kind of as intended. We also came up with, again, a scheduled protocol wireless that is working just fine, and is running full 5 megapixel images back to the central command center very smoothly at high quality. So it's definitely possible to use wireless for cameras as high as 5 megapixels and get good images across. They have different expansion plans, including ALPR, kind of for the future, plans to bring in other facilities over time. And they also were able to update their command center in the process. And I think in the central point here, they have a number of maps that you basically can click on different cameras, and that those cameras can then pop up on some of the other screens. But this gives a little bit of an idea of that system. And I think here you can see some of the images, very small, the 5 megapixel images of the different parking lots. Second case study would be an airport, one of the largest airports in the nation. They were looking at a perimeter protection system. And so a little bit of a unique use case in a sense. Fiber obviously is an option that is considered, but given the size of a typical airport, the cumbersomeness to dig up the facilities and so on, it just wasn't an option. So in the end, they and another element, I guess, that you find a lot with airports is that it's fairly wide open areas. Usually there are things like radar and other different spectrum wireless congestions that are encountered that we're quite familiar with, and that was one of the elements that we had to deal with in this project. And in the end, we ended up coming up with basically a parameter system that would be wireless, using light poles at intersections around the premises, around the airport areas. Also this system had built-in redundancy by having edge or local storage at each of these pole camera units. So even if the network is down or something else would have an issue, it would actually record images locally at the pole cameras. And then another element was to use that 4.9 gigahertz spectrum that was still available for this project, and allowed us to implement this quite smoothly. And then the analytics component, there is an analytics component to test traffic flow. So when traffic flow would stop, that measure can alert of some kind of issues that might be related to that. A last case study that I have here is related to utility. This is utility on the East Coast. They're looking at protection of a large number of remote utility-related sites. This is a typical kind of case where I mentioned the perimeter protection. These are really fenced-in areas that when somebody would approach the area and enter the area, that basically means that they want an alert. And let's say you have 50 or 100 sites. It's hard to keep a live view on all these cameras on all these sites. So the automatic detection in this case would be a tremendous benefit. And that is where this case study, I think, is a nice example of video analytics. So we're looking at a large number of sites as part of the challenge. Part of this challenge is also that not all these remote sites have good connectivity speeds, bandwidth speeds. Some do, some don't, but there's some variations there. So you want a lot of local intelligence at the site, and maybe just alerting at a lower speed back to the central site, preferably with some images, but at least that a lot of the intelligence is dispersed locally and decentralized. So we're in the campus of the university, we had a very nice path back to the central site. In this case, that's not the case. So again, every case is kind of different, and in this case, we had to think of the project a little bit differently. So the solution, we have a number of fixed cameras that basically cover the perimeter. I think they ended up being 1 megapixel cameras, but in terms of the analytics that is running on those cameras, it basically downgrades the images to a CIF resolution these days. It is related to the processing power available at the cameras, something that I expect to grow quite dramatically over the next 4 or 5 years. I think video analytics in general is something that still has a long development path to go, but I think this is a perfect example of analytics that's available today, that works well, that is affordable, and that has a very good use case. So with that, let me move on to the next bullet here. Right, so in this case, we have the add-on of a local server that is located centrally, or located at each of the remote sites, that has the software applications running so that there is only a limited bandwidth that needs to stream back to the server. The heavy analytics load is done, in fact, at the camera, and whatever else can be done at the server, the remote server. And then, again, what you end up with is alerting of any activity, any suspicious activity around the parameters automatically to the central site, and if bandwidth allows, along with video images that automatically are populated from where officers can take an action, call in police support, or whatever is required. A little bit more about video analytics design. I figured that this would be a nice case study. The blue lines here are basically the bore side of the cameras. So what you can see here, this is actually a radio tower that is within the site, and then this is kind of a building site. This is another building site. This is a very small example. We have more complicated ones, but I figured for this webinar I'll keep it simple. But basically you see that there are 4 cameras covering the 4 lines of the perimeter. And the next slide shows the software simulation of the fence lines, the buildings that are populated, and the views from all 4 cameras. So you have your camera 1, 2, 3, and 4. And the software simulation, it is very useful because it gives an idea of a person. As you can see, each image has a person kind of around the perimeters near the fence line, and then the software actually calculates the number of pixels and the size of this person and make sure that the video analytics engine has enough detail of that person, is not too far away or not too small, so that the analytics engine can work. So there's some pretty nice ways these days to design a system like this with analytics pretty accurately before implementation. So moving on to the case studies, again, a couple of things I wanted to highlight here today in terms of best practices. One is around video management solutions. There are a lot of solutions out there when it comes to video management software. To me, at a first glance, they all kind of look the same. They have the same look and feel, the same general features, and in a demo, depending on how well the person can do a demo, you'll be either impressed, but either way you get a very similar view. Roughly, my guesstimate is that there are 20 to 40 of these kind of software, video management, video software solutions in the market. I think that's a lot. I think it's almost too many, and I expect some market consolidation in this area. Now, when you look at kind of the market share, there's a few companies that really kind of dictate the market in terms of market share, and the size of the engineering team of those companies can be in the hundreds, and if you compare that with some smaller companies, they might just have 1 or 2 people that do most of the engineering. So when it comes to software, these systems are becoming more and more complex. They're becoming more and more similar, I would say, to kind of like a Windows operating system. So I do believe that a solid engineering team, I think, is something that gives a certain confidence that bugs are ironed out with new releases. That is always something that you have to keep in mind. This is software, so any issues are related to bugs, software updates, new features need to be negotiated. So all these things, I think, are important factors. There are also some packages out there that, frankly, are OEMs. So they just borrow the software from somebody else or part of the software. And that's also something that you might or might not be less or more comfortable with. Another element, even though we're talking about IP, and I think the university was one example, again, without going into specific vendors, but in my opinion, as a, kind of from a system integration or a consultant or an end user standpoint, I always kind of am worried about this conflict of interest when a VMS vendor, just a software vendor, if they also sell you the hardware for servers and storage, and if they also sell you the cameras. And I always sense this little bit of a conflict of interest where they, would prefer to sell their own cameras rather than something off the shelf or something out in the market. And I'm always a little hesitant. And there's some pretty large players where I kind of sense that little bit of a conflict of interest, and again, might be my opinion, but it's something that I'm always a little bit hesitant about. Another thing is that it's nice to see something in a demo, but what happens when you actually start implementing this? And IP video, it really is not as simple and straightforward as you might expect when it comes to setting up your switches, your network, making sure that bandwidth works everywhere, making sure that you have the right processing power in your servers, in your viewing stations, the network settings between UDP and TCP/IP and different multicasting and all these kind of different features. Once you start implementing, and obviously there's a difference between the two camera network and a 10 or 100 plus or hundreds of camera network. But when you start implementing, you will start seeing differences between packages more and more and more. So as you get more familiar, you will find out there are bigger differences that it looks at first glance. And these differences, they relate, for example, to networking options, flexibilities, capacities, capabilities of different settings, capabilities of dealing with remote locations, multiple locations, and all these kind of things. The processing requirements, I think, is an interesting one too. Again, without being specific, but we did a comparison between leading solutions when it comes to software, and we calculated a ratio of 4:1 when it comes to the number of servers or the amount of processing capacity. So certain solutions will allow you to run a lot more cameras per server than others. So some, you might say, are more efficient in kind of using up, server and processing capacity, and that doesn't apply for, let's say 16 cameras, but when you get to 50 megapixel cameras and plus, then you'll start seeing that these factors will weigh in as well. Flexibility and configurations, I mentioned already, and then features. There are different features, and without going into specifics, but some things like streaming video from a PDA, and the PDAs can these days be turned into a camera. That's kind of one of the newer features. SD support, so the memory cards that can be put into cameras, they can be used as kind of a cost-effective remote storage engine that then can be integrated with a central system. And there's many little features that are maybe less evident, but might make a big difference in the use cases. And then the other thing I mentioned already is, do you want a surveillance system, or do you look beyond surveillance to things like ALPR, access control, GIS integration, and those kind of things? So these are just some, again, nothing to kind of be very specific, but these are just general thoughts to keep in mind carefully when you make a selection. And of course, we're always happy to give you specific feedback, but these are some general feedback items on the software side. When it comes to the hardware, I'll call it the back-end design. There's really two elements here. There is the server component that includes storage. Basically, it's two things. It is processing power for, depending on the number of cameras, the number of megapixels, and so on, and sufficient storage. How long do you want to store the video? And for us, I think our lesson learned in that section for us is really that reliability is key. We've dabbled with some lower-end storage solutions, some newer storage solutions, some that claim to be, in fact, more reliable than others, ended up to be the least reliable. So I think experience in terms of having hardware solutions on the server side and the storage side that are reliable, I think is key, and still it has to have a certain affordability. Cost has come down incredibly when it comes to storage. In just last few years, we went from, I think, 500 gigabyte drives to these days, I think it's 4 terabyte, and I think I've heard of 6 terabytes drives now coming out. So I think when it comes to storage, and in parallel with the megapixel cameras, storage has become relatively very, very, very affordable, and that allows, I think, the end users to be a lot more flexible in terms of setting up expectations. Monitor solutions, Well, in the end, and I put this same graph that I had earlier, but basically there it's just a matter of having enough processing capacity on the workstation to handle 1 or 2 or 3 or maybe 4 screens at the same time, and then picking the size of screen that you feel comfortable and fits your space. There are the very, very fancy $1 million plus video walls that I've still seen with some customers from a couple years ago. I think that trend is kind of over. I think the flat screen TVs and screens and monitors are so affordable now that I think that is the logical path to build a nearly perfect video wall, but without that extra cost. So I think there are very affordable, very simple off-the-shelf solutions for creating beautiful monitoring solutions. And again, it's just a matter of kind of the processing power and the display configuration that fits your needs. This slide is a follow-on to a previous slide where we talked about bandwidth per camera. These are, along those lines, the storage per camera per day in gigabytes per camera per day. And this is done for H.264. I think they're a little bit on the conservative side. I think these days you'll see a factor, maybe even up to 50% better than what you see in these images. And I think going with the average motion is probably okay, but definitely for fixed cameras. You might need to round it up a little bit when you go with a PTZ camera, which has that high motion possibility. I think these are, I'm getting to my final slides here. A little bit about video analytics. We talked about it already. I do believe that video analytics still has a little bit of a ways to go, that there will be new entrants and a lot of movement in that market over the next 5-10 years. But overall, the leading packages have interfaces with the leading video management software solutions. It's easy to add anytime. This is not something you need to be very strict about from day one. You can try it in a couple locations. You can expand on it later on. It is something that, or at least you should be able to do that. So I wouldn't be worried too much about it. But it's something that you can really apply to your needs and to your flexibility. And I think in terms of a campus setting, parameter protection is an application that I think has proven itself, and there are cost-effective solutions to do that. I already mentioned that in that utility case study, most of the processing is done at the edge, at the camera, and I think more and more and more the cameras will have video analytics capabilities, probably from the video vendor more and more, and that those video capabilities are just part of the camera that you buy, and that those analytics then can send alarms to your standard video management software. I think that is a trend that will continue, at least for kind of the standard protocols that are available. And then my last slide here, it's kind of a grouping of some different little subjects that relate to complex video surveillance solutions and options. Besides that 4.9 gigahertz type of build-it-your-own wireless networking, there is that new option, which is cellular. It's you have to look for the LTE 4G type of option. You have to look for a cellular vendor that will allow you an unlimited package. And we've seen government users so far be quite successful in taking advantage of packages that are available in the market that allow use of unlimited data. And you have to picture that you choke a standard package of 1 gigabyte per month. You choke that package in a number of hours. So the standard packages that are available to the consumer will not really work when it comes to cellular. So, but as a government entity, again, we've seen some packages, unlimited packages available that maybe not forever, but at this moment there is that option. That allows, obviously, the option of a mobile pole camera unit. This is a system that we put up that basically moves from pole to pole, depends on the needs, and that was kind of the intent of that system. Of course, covert systems, and this is just an example of that, it allows you to be more subtle in your investigations, and again, cellular is another factor that really helps in keeping it a little bit more subtle. Other systems, and in kind of as a tie-in with that video management software, the more advanced video management software will allow you to put trailers up, maybe have local edge recording within this device, but then have a cellular connection back to your central site. And again, the sky is kind of the limit these days, so it's another kind of avenue of a specialty application. So again, I mentioned already these kind of remote applications, such as also the utility case study that I gave with remote sites that might not have perfect connectivity, edge storage, edge servers, SD cards, those kind of options at the edge will make it a lot easier to deploy remote video and wireless video systems. So with that, Roy, I don't know if we have some wrap-up questions that we can address.
Yeah, Jasper, we have a number of questions here. Could you give an idea on the type of bandwidth required for 5-megapixel camera per your university case study?
Sure. Yeah, that's a good question. And if I would go back to my bandwidth slide, let's see if we have an example of a 5-megapixel at average motion. Maybe it's something like 12 frames per second. So I think we have a fairly conservative number here, if I'm not mistaken, in a number of megabit per second. In the end, I think I estimated it around 3 megabit per second, and I think we ended up getting a very, very good image at only 1.5 megabit per second. So I was very impressed that, again, these numbers I think are a little bit more conservative than they should be, but we've seen with the recent technologies in cameras at 5 megapixel, we've seen a very, very, very good image at 1.5 megabit per second. So I was very surprised and impressed how well the image is compared to the limited bandwidth, relatively speaking, that we're looking at. So
okay. You mentioned about LTE. With Verizon changing the terms of their LTE use for public safety and increasing the cost for bandwidth, has this deterred the use of using LTE for video surveillance?
Well, if that refers to the fact that there have been some unlimited packages, and if those unlimited packages are no longer available to government, that would obviously make things a little bit more difficult. So if there are no unlimited packages available anymore, and again, I think so far our customers have been able to either be grandfathered in or whatever the situation is, but so far they've been lucky. But the other alternative would be that you would have to kind of go with some kind of passive system where you set up your remote cameras over cellular in a way where you have full edge storage and full edge capacities, and that only on demand. Certain alarms, certain event situations, certain hours in the week, maybe Saturday night at the at a bar that people leave at closing hour, where you expect problems, that only under limited situations that you look at the cameras, and that you look at those cameras at extremely reduced rates, where you go back to something like like 50 kilobit per second. So the cameras that at least we deal with, they allow for multi-streaming, so you can have the stream that goes over cellular, you might limit it to something like 50 kilobit per second. And for example, the one that we're recording locally, we might go as high as 1 or 2 megabit per second. And in that case, if you have images that you have to download a minute of high quality footage, you just kind of analyze the 50 kilobit per second at your central site, pick the time from those 2 or 3 minutes of evidence that you need, and then you pull that high quality over cellular, but you do that at a lower rate, or at a higher rate, but only for the 2-3 minutes that you need. So there are probably ways to play with it, and it depends on your limitations that you find with Verizon or another provider. But Ideally, you negotiate some kind of a limited package. If it's limited, then it might make the use cases a little bit more limited than what they at least have been so far.
Okay, are you using some special provisions for night views of the docks?
At this point, no. And Jim, I don't know if you're lighting along the docks, but in my knowledge, of course, if there is very limited ambient light, it would make sense to have some IR, infrared illumination. If that is not the case, if there is some ambient light, in our experience at least, the camera technology today has matured quite a little bit, particularly when it comes to IP cameras, and they have shown good low light sensitivities, particularly new camera generations. But Jim, maybe you can comment for your case.
Yeah, that was one of the trade-offs. When we went to RFP for this project, we thought we wanted the very best of the infrared cameras or the FLIR cameras. The river in front of our facility is about 750 feet wide, and we've got the dock is well lit. So we ended up after going through narrowing the scope of the project down and trying to get the best bang for our buck, we ended up staying away from the infrared cameras. And what we've experienced so far with the lighting that we have on the dock and the limited amount of traffic that's on the river, our primary goal was just to be able to view our immediate berth area, which extends from our dock out about 85 feet. We've got good visibility of that from the dockside cameras. So that perhaps something that we might consider adding on as we scale the system up.
Okay. Jasper, do you perform any simulation to verify the field of view of each camera?
Well, in this particular case study that was shown, we did do exactly that. But it depends on case by case. But we do have the software tools to do those kind of analysis as that one case study shows. So it's again, it depends a little bit, but it's definitely possible, yes.
Okay, on the University of Texas project with 75 5-megapixel cameras, what was the typical frame rate?
Good question. So combined with that 1500 megabit per or 1.5 megabit per second per stream at 5 megapixel, I think it's still around 10 frames per second. Somewhere, maybe it was a little less. I think it's between 5 and 10 frames per second. So they sacrificed a little bit the frame rate, and that's probably where my estimate of 3 megabit per second, they might at that rate you might need. At 3 megabit per second you might see closer to, let's say, 10 to 15 frames per second, and maybe at that 1500 1.5 megabit per second, I think it ended up in the 5 to 10 frames per second range.
Okay, we have a number of other questions, but I'm probably limited to 3 more in the interest of time. Regarding the university project, did they have to get an FCC license to send on 4.9 gigahertz?
Yes, in general, for 4.9 gigahertz, there is a requirement to file licenses with the FCC, and government entities have the ability to get those licenses.
Okay. Do you find the H.264 is not equal and that storage capacity changes by camera manufacturer and not by compression?
Yes, absolutely. So H.264 encoding is not the same for every vendor, absolutely. And I don't think it's even been the same over time with the same vendor. And there are, with H.264, there is, maybe just the standard way without any measures, and then even then I think it's not the same. But when you start looking at, and again, what we like to do is to manage the bandwidth a little bit. As we spoke about it in the previous webinar, we like cameras that allow us to tune a little bit and tighten a little bit the bandwidth without compromising the quality of the stream. And some manufacturers allow that very successfully, and others do terrible. And a camera might be slightly cheaper, but you might require 2 or 3 or 4 times the bandwidth. They might both, be called H.264, but if a camera comes at 3-4 times the bandwidth at 5% better quality, then it's not worth it. So it's again that trade-off where the trade-offs are everywhere, right? So in the end, I think we try to find a trade-off where if we can cut the bandwidth by 2 or 3 times, but only lose 5% of our quality, then we think that is a smart move. Obviously, when you start seeing the quality difference, then you might have to take a step back. But no, not all cameras, and not the encoding for all cameras is made equally in our experience.
Okay, last question here, Jasper. Did you find the addition of ALPR cameras to be beneficial in the port project?
Well, I think in general, and for this project, it was Jim. I think you can clarify that better than me. But I think in general, I think the ALPR cameras have a clear value. I think it's a little different from having just a regular camera and being able to register license plates after the fact. The ALPR cameras add the capability, first of all, to be much more accurate, secondly, to do that automatically, and I think there are a lot of use cases for those in general. In the port project, it was always part of the requirements, and Jim, I think it is just part of your security, your security system for the port to make sure that you have registration for every car that goes in and out.
Right. Yeah. From a security standpoint, we wanted to be able to automatically record that data, and at some point in the future, perhaps even tie that into the municipal emergency operations center or the state emergency operations center. So as hot lists come out, in a particular locality, we could have access to that, and then our data feeds back to the central monitoring points. The other aspect of it for us is for cargo transactions, when trucks and trailers come in, that license plate is sometimes part of the data trail that we record and track in our inventory system. So tying that in as the WMS and the terminal operating software suites catch up with the technology, already having the cameras there and already capturing that data, our hope is that we'll eventually be able to link that directly into a terminal operating system and automatically capture that.
Yeah, and I think for me, the ALPR cameras, I think the key element is that, yes, they are more expensive, but if you are looking at a large system, a large campus, whatever that is, if you can reduce the exit entry points to a manageable number of lanes, then I think ALPR becomes a very interesting option, because you can use general cameras that overview your campus without maybe facial recognition or license plate recognition, but you can track back a vehicle or whatever that is back to the entry point where you have all the details available at that entry point. So I think the combination of ALPR cameras and surveillance cameras, I think that's a very powerful combination.
That's all the questions we'll take for now, Jasper. In the interest of time here, we're closing into the ending of our session, so I'll turn the floor back over to you.
Okay. Well, thanks everyone for joining us today. We appreciated this second opportunity to talk about campus surveillance. I hope that it was useful, that it contains some useful information. And Jim, thank you so much for bringing that end user and real life experience with a system like this. So again, thanks to everybody. We will send a follow-up email out to the attendants so that you have a copy of the slides that we are presenting here today, as well as a link to the kind of a copy of or recording of this presentation that you can use as kind of a reference point. So with that, thank you very much, and we will close the session.
Thank you, everybody, and we hope to have you in a future session. Thank you, Jasper. Thank you, Jim.